Okay, so the one new piece is this sheet of notes that I gave you yesterday. It's entitled Angled Projectiles That Are Not Ground to Ground. It's on the back side of the question we did yesterday, what if you don't have the angle? Okay, so it's time to look at angled projectiles that aren't ground to ground. Okay, so we did the angled ones that were ground to ground. So the ones that aren't ground to ground are going to have two options. They could start at some height, get fired at an angle, and end up lower down. This would be like kicking a football off the roof. Or they could start from the ground and get fired and go up and end up on the roof. Or this could be, standing at home plate and hitting a ball into the stands. Okay? Really the only difference between them is this one, the delta dy is going to be negative because it ends up below where it started. Whereas in this one, the delta dy will go in as a positive because it ends up above where you started. Okay? So if we think about, we're still going to divide them into the x and the y. So we'll have vix is still vi cos theta. Ax will still be 0. Delta dx will still be the range. Okay, so that won't change. In the y, vi will still be vi sine theta, going up. In both cases, it's going up. Ay will be 9.81 meters per second squared, and it's still down. The delta dy for this one will be down, whereas over here, all the x's would be the same, but the y, it'll be viy sine theta. Oops, it'll be viy is equal to vi sine theta, still up. Ay will be 9.81 meters per second squared, still down. But this time the delta dy, whatever it is, it'll be up. Okay, so you'll just have to watch your positives and negatives. The other thing that's different is finding the time up. You can still find it, and you can still find it exactly the way we did in the other ones, the time it takes to go up. In that case, it would be here. In this case, it would be here. But in these questions, it's not helpful, right? If you double it, it gives you some time here, which I guess is nice, but it doesn't tell us anything about the total time. And if you double this one, well, again, it doesn't tell us anything about the total time. So in this one, using the ay equals vfy minus viy over delta tu is not going to be helpful. To get the time in this one, if you know the height, you're going to use delta dy is equal to viy delta t 1/2 ay delta t squared. And it will be a quadratic, right? Because neither of these terms go to 0. So let's suppose that I have a height of, just a second, I have a question done. Let me step back and see what I picked. Let's suppose we have a height, we'll do this one, of something like 248 meters. And we have a VI here of 30 meters per second. And, no, I lied. It's 20 meters per second and 30 degrees. 20 meters per second and 30 degrees. So our first step would be to find the time, and we'll do it with this. Now, just to fill our numbers in here so we don't get screwed up in our signs, delta dy then will go in as negative 248 meters. Viy will be vi sine theta, so it'll be 20 meters per second sine of 30, delta t, plus 1/2 negative 9.81 meters per second squared, delta t squared. And so then rearrange it in ax squared plus bx plus c form. And remember, I always say try to make your a term positive, so bring it over here. So it'll become 4.905 meters per second squared delta t squared. This term will become minus, sine of 30 is 0.5, so 10 meters per second delta t. And this term staying on this side, so it's still a minus 248 meters equals 0. And then you would do your quadratic. So delta t will equal negative b, so positive 10 meters per second, plus or minus square root negative 10 meters per second squared, minus 4a, 4.905 meters per second squared, c, minus 248 meters. And then all of this is going to be divided by 2 times 4.905 meters per second squared. So delta t will equal 10 meters per second plus or minus, under the root, this first term will be 100 meters squared per second squared. The minus in the minus will be a plus, 248 times 19.62. So it'll be plus 4,865.76 meters squared per second squared. And that gets divided by 9.81 meters per second squared. So adding under the root and taking the square root of it, we end up with delta t is equal to 10 meters per second plus over 9.81 meters per second squared, and delta t is equal to 10 meters per second minus over 9.81 meters per second squared, and this is 70.468 meters per second and 70.468 meters per second. Now obviously, in this question, this one's going to give us a negative. All right, so we'll take 10 away from that, divide by 9.81, and we get negative 6.1639 seconds. Obviously, it cannot be this one, so it has to be this one. So we add 10 to that and divide by 9.81, and we get 8.20267 seconds. And this is the full time that we found. So then once you have that, then we can go back and find anything we want. We can find our delta D, we can find our VF, exactly as we did before. So the only thing that changes is how we have to get our time here. Okay? Interesting. I don't have the same answer in mine as in what I did. So I may have screwed this up. Because under the root here, I have 900. So what did I do? 4 times 4.905 times 248. Maybe I used different numbers. Plus 100. Square rooted. Yeah, I got the same thing, so I must have screwed up the other one. Okay, so homework over the weekend. What would I like you to do? Because you do have a few days off. So the first thing I would like you to do is page 543, numbers 9 to 12. Okay, 543 numbers 9 to 12. And then on the back side of the angled projectile sheet, so on the back of the sheet you were working on, you had done to number 3. So if you would do 4 to 7, okay, so you don't have to do 8 yet. So 4, that's for 8 questions. Besides that, you have the half-page spring assignment that is due on Monday. No, make that Tuesday. And you have your lab, the horizontal projectile lab, and let's say Wednesday for that. Okay, now in that horizontal projectile lab, no calculations other than what you already did in class. So in your results, it'll be the table with your times, so your 10 times, and then it'll be all the calculations that you did in the lab. And then don't forget, under the results, did you hit it? Did it take you 12 tries? Did you have to redo it? But that goes in the results. Sources of error, we can talk about on Tuesday quickly if you want, but I would think at this point you should be able to get them. If there's any you're not sure of, feel free to ask in the group. Okay, so the same write-up as always. In the conclusion, don't forget to talk about who higher the ramp, was it a bigger range or a smaller range? And again, on Tuesday, I can give you 2 minutes at the beginning of class to compare ranges if you want to. Okay, have a wonderful weekend. Please do these. See you Tuesday.